good this time. All right. Again, welcome to the review of the review that we reviewed yesterday. Okay? All right. So today we've got some more examples that we can go through of things that will be on your test. Your test opens this afternoon. I'm going to open it at 3 o'clock today, and you will have until Monday night at 11:59 p.m. That's when that test window closes. Okay? All right? So you have until 11:59 p.m. Monday to get that done. Okay? It's a few questions. I'm not going to lie to you. There's just no way to do like questions of different, with like A, B, and C answers without, putting them in as 3 separate questions. So I think I tried one, but you guys are going to be the guinea pigs on that. So, all right. So we have, if we're looking at the old slides today, looks like we got 4 examples, and then we'll open up the floor to questions and answers that you guys may have from the review packet, which was on Monday. You got that review packet to do. And then, or anything else that may be out there, okay? All right, so here we go. First example, solve that and give me exact answers, please. Solving this one with an exact answer, please. Sure, all right, here we go. So first off, I would combine the 2 logs. I would condense the left side. I would condense that to become log base 3 of x times x minus 8. And that's going to equal 2. Now I've got a single solitary log that I can't do anything else with, so I'm going to switch forms with it. So this is going to become 3 squared equals x times x minus 8. 3 squared is 9. X times x minus 8 is x squared minus 8x when we distribute. Because we have a squared term with a linear term to go along with it, we're going to get it equal to 0. We're going to extend my page. Then we're going to factor. If I factor this side, if possible, that's going to be x minus 9 and x plus 1. Then I would say x minus 9 equals 0, so that gets me x equals 9, x plus 1 equals 0, x equals negative 1 there. Since I have 2 answers, I'm going to go back then to my original equation, and I'm going to test it out. So if I test this, let's go with we'll go with black down here. So if I test 9, I would have log base 3 of 9. Log base 3 of 9. What exponent do I put on 3 to get 9? That's 2. Okay? Plus log base 3 of 9 minus 8. 9 minus 8 is 1. What exponent do I put on 3 to get 1? That's 0. 2 plus 0 is 2. And 2 is equal to 2. 9 checks out. Then I'm going to check out negative 1. Log base 3 of negative 1 is not possible. The argument, the answer, if you will, has to be positive. So it fails right there. So negative 1 fails. So the only answer that I get here is x equals 9. Now, I will caution you that sometimes a negative answer, when you plug it back in, will work. So just because you get a negative down here at the bottom doesn't mean it automatically gets extenuating circumstances and becomes an extraneous solution. Okay? So just make sure you're still doing that check. Okay? Any questions, comments, concerns, parables, hyperboles to go along with that one? We'll go with the thumbs. Thumbs up is good. Thumbs to the side is, we probably could use a little more practice on ones like that. Thumbs down, we got some issues. Okay? All right? Okay, those that are giving me the kind of 45-degree angle, half issues, half good, make sure that you are asking questions as we're going along with these. Okay? Please, at this time, sketch this graph. Sketch the graph of this particular function. So first got to look at what kind of a function this is. Anybody want to take a shot at what kind of a function this is? A 1 in 3 shot? Exponential, logistic, logarithmic, one of those three? Don't everybody speak at once? Drew, what kind of a function do you think this is? Logistic, yep, exactly, because it's exponential, but the exponential is in the denominator. So this is a logistic function. So that's going to tell me two things. Because we've established that it's a logistic function, two things get told to me right off the start. The first thing that gets told to me is that I have a horizontal asymptote at y equals 0. Second thing that gets told to me is I have a horizontal asymptote at y equals what? Anybody? Y equals what is my other horizontal asymptote? Carson, what do you got? Y equals 100. Nice job. Okay? Y equals 100. So, and we get that one, that upper horizontal asymptote is our limit to growth from right up there. Okay? So we know that this function, because it's logistic, it's going to start out along on the left side along my horizontal asymptote. It's going to grow exponentially, and then it's going to level off and end on the right side by my upper horizontal asymptote. We just have to find what that y-intercept point is, 0, something. It's the easiest one to find. Okay? So if I plug in 0 for x, then that's going to give me 100 over 1 plus 9 e to the 0 power, because negative 0.7 times 0 is 0. E to the 0 power is, you can just show me fingers on this one, e to the 0 power is 1. Yes. 1 times 9 is 9. 9 plus 1 is, fingers, 10. Yes. So this becomes 100 divided by 10, which is 10. So we go through the point 0, comma, 10. So we start out along here, grow exponentially, and level off. Shabam! There is the sketch of our logistic graph. Okay. Love it. Next one, go for it. Oh yeah. What kind of function we thinking? Exponential, yay. Logistic, yay. Logarithmic, yay. I saw a head shaking on exponential. I would agree that this is an exponential function. We've got a base with an x, the variable in the exponent that makes it an exponential function. Okay? So I'm looking at that and I'm saying to myself, this minus 2 down here means that my horizontal asymptote, which would normally be at y equals 0, now gets moved down to y equals -2. Okay. Two easiest ones are when I have an exponent of 0 and when I have an exponent of 1. So x equals 0 and x equals 1. If x is 0, 3 to the 0 power, that's 1, times 4 is 4, minus 2 is 2. Exponent of 1, 4 times 3, or 3 to the first power is 3. 3 times 4 is 12, minus 2 is 10. This one is going to start here. It's going to be a growth, and it's going to grow rather quickly. Good? Love it. Okay. Go for it. So this one's a logistic, or excuse me, I almost said logistic. This is a logarithmic one, okay, which is an inverse of our exponential, because logs and exponentials are inverses of each other. Okay? So normally an exponential would have y equals 0 as my horizontal asymptote. A log function, then, because they're inverses, is going to have x equals 0 as a vertical asymptote. Okay? Because the x's and y's get switched. Normally, on a y equals ab to the x minus c plus d type 1. Okay? So normally this C right there moves it horizontally. And D then is our vertical. In a log function, this is our horizontal shift. And this is our vertical shift. With that being said, we have x minus 1 in the argument point or spot. So that's going to shift our whole graph is going to shift one spot to the right. So that puts my vertical asymptote at x equals 1 here. Then if I go through and I try some points, now because my base is 3, I want to try x values that are multiples of 3, or that x minus 1 then becomes a multiple of 3. So the first one that I'm going to try is 2, then 4, and then 10. Now I chose 2 because 2 minus 1 is 1. Log base 3 of 1 is 0. I chose 4 because 4 minus 1 is 3. Log base 3 of 3 is 1. I chose 10 because 10 minus 1 is 9. Log base 3 of 9 is 2. So my green point would be here. My orange point 2, 4 would be there. And my red point would be there. And there's the graph of our logarithmic problem. Okay. Now, a couple of things to do before you get to 3 o'clock today. Okay. So first thing is, go back and make sure that you have taken the 3.1 to 3.3 formative. There are still 2 people that have to take that formative yet in here. And there is a couple people that still have an opportunity to get a 9 on that one. So that's a good spot to review for that one. Next, what you should also be working on is the exponential log worksheet. That was a front and back worksheet from last week. That one needs to be turned in. And in here, 7 of you still have to turn that one in. And there's 1, 2 of you that have some fixes to do on that one. Okay? On top of that, you have the Chapter 3 review packet, which was assigned on Monday of this week. That's on It's Learning. That, I believe, is a 3-pager, and that one can be turned in at any point in time. But again, you want to do that prior to taking the test. Okay? Reminder that before you take the test too, make sure that you clear your Chromebooks history. What I found last night was that I have some images on my Algebra 3 test that's going on today, and people's images weren't loading until they cleared their browser history on there. So it kind of needs to just kind of be reset every once in a while. So before you take the test, so you don't have that, because there's a time limit on this test, make sure that you clear your browser history so that you don't run into any issues. Okay? With that being said, the test is made, it's ready to go. We will open it for you at 3 o'clock this afternoon, and you have until Monday the 19th, I believe is what it is, Monday the 19th to get that test done, okay? Along with the 3 things listed up there on the screen, okay? That's all I got for you. And yeah, don't forget about your NTC dual credits too. If I sent you an email about that yesterday. Okay. Okay. Mr. Roth just told me that he created a folder on It's Learning that's just the NTC stuff, but that was also from September 28th is where all the links are to on that one. So don't forget about registering for NTC. With that being said, I got nothing else. I'll hang out here for the next 20 minutes or so in here and answer any questions that people might have. So have a good day. Good luck on your test.